for watching. This is Lab 2, Charge Tape Revisited. The purpose of this lab is to build on previous results by creating a more sophisticated model of the two pieces of charge tape. Here's a brief preview of the results for the experimental model. We calculate 4.9 times 10 to the negative 9 coulombs, and for the computational model, we computed 2.2 times 10 to the negative 8 coulombs. The first concept that we're going to be using is electric force. We're also going to be using the superposition principle and the equation for an electric field due to a rod. The next concept important to this lab is gravitational force. And finally, we're going to be using Newton's third law, which says that for every action, there is an equal and opposite reaction. Here are the key assumptions from this lab. The main difference from the last lab is that the bottom tape is approximated to be a line charge. In the experimental model, the top tape is approximated as a point charge, and in the code model, both tapes are assumed to be a line charge, but all infinitesimal forces on the top tape are assumed to point upwards. This is the experimental model for the excess charge on the tape. The bottom tape is assumed to be a line charge, and the top tape is assumed to be a point charge. The gravitational forces on the upper tape are balanced out by the electrical forces on the upper tape, giving us this middle equation here. When we solve for QT, which is the excess charge of each tape, we get this equation here, which gives us the excess charge on one piece of tape. This is the computational model for excess charge of the tape, which sums all of the infinitesimal forces on the bottom tape and the top tape. So in this case, both the bottom tape and the top tape are assumed to be a line charge. This is the procedure and observations, which we're just going to go over really quickly since it was covered in the last. The results, the only difference here from the last lab is that we recalculated the excess charge using our new model that approximates the bottom tape as a line charge. At the computational model, the initial conditions for the model are Coulomb's constant, the gravitational constant, the mass of the tape, and the distance between the tapes, which was calculated by trial and error to be 2.2 times 10 to the negative 8 coulombs. We also have a function to calculate the electric field between two charged particles. There's also a function to model a line charge, which is used to model the top and bottom tape. Finally, the electric force is calculated by iterating over the charges along the bottom tape and the charges along the top tape, and summing up the electric force between each of those two charges. This is the output of the computational model. The blue spheres represent the lower tape, the red spheres represent the upper tape. The yellow arrow represents the gravitational force on the upper tape. The white arrow represents the electric force on the upper tape. And each of the green arrows represent the electric force at different points along the upper tape. Note that the magnitude of the electric force is roughly equal to the magnitude of the gravitational force. This is because the value for the excess charge on the tape was modified by trial and error so that these two values would more or less align. To the discussion, here we compared the results for the excess charge between the experimental model and the computational model. For the experimental model, we calculated 4.9 times 10 to the negative 9 coulombs. For the computational model, it was roughly 5 times as much at 2.2 times 10 to the negative 8 coulombs. Sources of error. First, the charges may have been different between the two pieces of tape. The upper tape was held down to the surface that was taped to, so it might have floated higher if it wasn't taped down. The upper tape was approximated as a point charge in the experimental model, which might have overestimated the charge. The net force due to each dq on the upper tape was assumed to be upwards in the computational model, which might have underestimated the charge. And finally, the tape is curved in the experiment, so the difference is just the distance is different at different locations along the tape. What if we had used point charges instead of line charges to model the experiment? experiment? Well, when comparing to the results of the previous experiment where we had used point charges, the calculated excess charge on the tape is significantly lower. Why do these estimates differ? Well, it makes sense that the line charge would be significantly lower because when distributing the charge along a line, a lot of the charges become further away, and charges that are further away create a lower force.